Hello everyone, I am Julka. Today we'll talk about continuity. A function is said to be continuous if left hand limit equals to right hand limit equals to value function. Or this implies when we draw the graph of the function, there is no break in the graph. A function is defined as fx equals to 2 plus 3x when x less than 1 and 3 plus 2x when x greater than equal to 1. Show that fx is continuous at x equals to 1. For this we'll check left hand limit, right hand limit and the value of function. So we'll start with left hand limit. Left hand limit is limit x tends to 1 negative. 1 negative means less than 1. So function is 2 plus 3x. We put x equals to 1 minus h. X tends to 1 and s tends to 0. Now limit s tends to 0, 2 plus 3, 1 minus h, and put limit s tends to 0 here, we'll get 5. Now right limit is limit x tends to 1 positive. 1 positive means more than 1. The function is 3 plus 2x. Put x equals to 1 plus h. So x tends to 1 and s tends to 0. So limit s tends to 0, 3 plus twice of 1 plus h. Replace h by 0 and we'll get 5. And the value function at 1 equal to 1 at 3 plus 2x. So replace x by 1 we'll get 5. Here left hand limit equals to right hand limit equals to value function at 1. So function is said to be continuous at x equals to 1. Next example. A function is defined as fx equals to mod x upon x when x is not equal to 0. This implies either x less than 0 or more than 0, or it is equals to minus 1 when x equal to 0. Show that fx is discontinuous at x equal to 0. Now again we check the function for left hand limit, right hand limit and value function. Starting with left hand limit. Limit x tends to 0 negative. So this implies less than 0. So function is mod x upon x. Put x equal to 0 minus h. X tends to 0, so s tends to 0. Limit s tends to 0 and replace x by 0 minus h. And now we have minus h upon minus h, which is equals to minus 1. Now right limit is limit x tends to 0 positive. Mod x upon x. Put x equal to 0 plus h. X tends to 0, so s tends to 0. Limit s tends to 0, replace x by 0 plus h. Now we have h upon h. When we cancel this 2, we'll get 1. Left hand limit is not equals to right hand limit. So limit does not exist and there's no need of checking the function, because when the limit does not exist, then function is discontinuous at x equal to 0. So always remember that if left hand limit equals to right hand limit equal to value of function at a point of particular point, then function is said to be continuous at that point, otherwise discontinuous.